students, I welcome you all in the sixth lecture of CFG, and I welcome you all in the initiative of TEQIP Faculties, that is Let's Crack the Gate. I hope all of you are enjoying these videos and definitely you are gaining some knowledge from it. Okay, so in this lecture we are going to see the conversion from CFG to CNF, that is context free grammar to Chomsky normal form. Similarly, in coming lecture we are also going to see the conversion of CFG into Gray-Buck normal form, that is GNF. Okay, before starting this lecture, in previous lecture we have already seen about the simplification of grammar. In simplification we have seen that the current grammar, that is CFG, is having some useless symbols, some epsilon productions, and some we can say that unit symbols, and that things are not important in the grammar. Okay, so that's why we have removed by them that symbols, or we can say that unit productions, by some elimination method. Okay, so whenever we want to convert the CFG into CNF form, definitely we need to remove the epsilon productions, unit productions, if that present in the grammar. If that is already removed from the grammar, then no problem. And one more thing about the CFG is that CFG, definitely CFG is the grammar, and by using this grammar the context free languages are generated. Okay, so whatever the context free languages are generated, similarly for that languages we can write the context. We can say that every CFG grammar is converted into the CNF form. ओके, सो वी कैन नॉट से दैट कि कोई एक एक्स्ट्रा ग्रामर है जिसको हम बस सी एन एफ में कन्वर्ट कर सकते हैं और दैट इज़ नॉट ए सी एफ एल लैंग्वेज. ओके, all the grammars which are converted into CNF form are accepted by, or we can say that are the context free languages. Okay, so let's start what is meant by CNF form. Okay, so one thing is that what is meant by Chomsky normal form. So it is a context-free grammar. So let's see the definition about it. A context-free grammar G, a grammar है context-free, that is G, is in Chomsky normal form. When we can say that the grammar is in Chomsky normal form, if every rule or production is of the following form, जिसमें हर एक प्रोडक्शन कौन से फॉर्म में होना चाहिए, either this form or either this form. Okay, so first rule is that A produces BC. Okay, and both B and C are non-terminals. Okay, that is meant by variables. Okay, and another production is like A produces small a. Okay, means it will produce a single terminal. Either it will produce a two non-terminals or single terminals. Okay, then only we can say that the given CFG is in CNF form. Otherwise, even if we get a single production which is not in the form like this, suppose we will get a production like A produces small a and capital B. Okay, so then we can say that this is not a this production is not in CNF form, or we can say that A produces BC, or इसके बाद भी अगर A आता है, then whatever comes after this, if starting from terminal and after that any number of sequence of terminal or non-terminal, then we can say that this production is not in CNF form. Okay, also suppose one more production is there, B produces capital A small a. Okay, this is also not allowed in CNF form. Compulsory it should contain either two non-terminals or one terminal. Okay, and remember one thing about this, the rule S produces epsilon, where S is a start symbol. Means suppose the rule producing there is a rule, S is producing epsilon and S क्या है starting symbol, then it is not excluded from CFG in CNF. ओके, जब भी हम कन्वर्ट कर रहे हैं CFG टू CNF, अगर उसमें कोई प्रोडक्शन हो, ऐसा हो कैसा, S produces epsilon is there, then we will not remove this because this is the starting production and we are not going to remove this, we will accept this in converting into the CNF. Okay, otherwise after if like this, okay, let me write here, S produces AB is there and A is producing epsilon is there, then compulsory we have to remove this A produces epsilon because this is not a starting symbol, starting symbol is S. Only in the case of starting symbol it is producing epsilon, then only it is accepted, otherwise we have to eliminate that. Okay, so remember these two things because we have to accept these two things only. Okay, either two non-terminals or one will be allowed. Okay, so let's see the algorithm of conversion of CFG into CNF. So let's see the algorithm. So there are 5 steps. First step says that if the start symbol yes occurs on the some right side, means suppose the production is like this, yes B is producing AS suppose. Okay, so start symbol is yes and it is occurring on the right side, then create a new start symbol yes not and new production yes not produces yes. Okay, अगर स्टार्ट सिंबल यस है वो क्या कर रहा है राइट हैंड साइड में ऑकर हो रहा है, देन वी विल क्रिएट ए न्यू स्टार्ट सिंबल दैट इज यस नॉट produces yes. Okay, and yes is producing now this one. Okay, means स्टार्ट सिंबल अगर राइट साइड में ऑकर हो रहा है तो हमें नया स्टार्ट सिंबल प्रोड्यूस करना है. ओके, नेक्स्ट स्टेप ये कहती है कि if our CFG contain epsilon productions, then we have to remove that epsilon productions. If epsilon's productions are not there, then we will move to the third step. That third step says that if the grammar contains the unit productions, then remove that unit productions. Okay, the next step is that replace each production A produces B1 B2 up to Bn where n is greater than 2. Means suppose B is producing like this B C D E. Okay, so we have to replace this where n is greater than 2. Yes, 1 2 3 4 n is greater than 2. So I will replace this one with A produces B and I will use Z, and instead of Z what is there, Z is producing C D E, I will write. Okay, again what to do, next it says that repeat this step for all productions for symbol. Okay, now we can clearly see that in RHS we are having, so we will repeat again same step like Z is producing C D E, so I will write Z is producing C D, instead of D E I will write W and W is producing D E. Okay, like this I will do. Okay, so finally we will come with only productions which are allowed in CNF, that is this is first production, that is both are non-terminals at right side, and again Z is producing CW, both non-terminals at right side, and W is producing DE, that is both non-terminals at right side. Okay, so this is satisfying our the rules of CA. Okay, next final step says that if is in the form of A produces AB is there, A is producing small a capital B where A is terminal, small terminal is a terminal, because we have already assumed that whichever is in small letters are the terminals and whichever are the in capital letters are the non-terminals. Terminals, then the production is replaced by, how to replace this production, because what CNF says that either it will contain both non-terminals or single terminals. यहाँ पे क्या है, एक टर्मिनल है और एक नॉन टर्मिनल है. So we have to replace this terminal with one of the non terminal, and I will represent that A produces XB, and instead of X I will write a, both these things are allowed in the CNF. So we have to repeat this step for every in the okay. So let's see the regarding the CNF. We will take one CFG grammar, that CFG into the CNF. Suppose this is the grammar given to us, and this grammar we have to convert into the, okay, so let's, so this grammar we have to convert into the CNF. Okay, okay, so grammar is having the productions like S is producing ASA or AB, then S is again producing capital B or S, and B is producing small b or epsilon. Okay, so our first rule says that whenever the grammar is having start symbol at the right side, then we will create a new start symbol, that is s not or s1 or s2, anything, whatever will be the convenient to us. Okay, so we will check whether start symbol is outward on right hand side or not. Okay, so s is the start symbol, and in very first production we can see that s is already occurred in the right hand side. Okay, so that's why we will rewrite this production by creating new production, that is s not is producing s, and all other productions are as it is. Okay, so I will write asb is producing asa or ab, and similarly s is also producing capital B or capital S, and B is producing small b or epsilon. Okay, so this is according to the step number first. Okay, so let's see second step, whether we have to check whether it is having the epsilon productions. So here I am saying that there is a one epsilon production, that is B is producing epsilon. B is producing epsilon. Uh, so I will, based on the elimination method of epsilon productions, I will identify the nullable variables. So nullable symbols, which are they? B is one of them, and S is also one of them, because I will put here, then I will get a nullable symbol as S is also a nullable. Okay, just, just a minute. So according to this grammar, our new start symbol is S naught. Okay, so nullable symbols we got. We'll write nullable symbols. Which are they? First is B, and after, if I will put instead of B as epsilon, then S is also a nullable variable. Okay, so what I will do, I will write all the production with or without nullable variables. So with nullable variable is yes, and without it, nullable variable is nothing. Okay, so S not produces yes, and S is also producing A, yes, A. Okay, so with nullable variable ASA, and without nullable variable we will get AA. Okay, without nullable variable, just a second, just a second. Sorry, actually we have taken here yes, actually this is A, capital A. Okay, so this is also capital A. So we can say that B and capital A are the nullable variables. So I will erase this, I will rewrite this. Okay, S is not a nullable, because if I will put epsilon here instead of B, then A is also nullable symbol. Okay, so S is producing ASA. So with ASA will come, and suppose I will put instead of this A as epsilon, then I will get SA, and instead of this if I will put epsilon, then I will get AS, or both A becomes epsilon, then I will get S. Okay. Similarly, B is also a nullable variable. So with or without nullable variable. So with nullable variable, it will come AB, and without nullable variable, it will come A. Okay. Next, A is producing capital B or S. So A is producing S, and with nullable variable is B, and without nullable variable is nothing. And finally, B is producing small b. Okay, so we have removed this epsilon, and similarly we have removed this A produces B, that is A producing epsilon. Okay, so A is directly producing now small b. Okay, so we got this grammar after the removal of epsilon productions. Okay, so next step says that if there are unit productions, then we have to remove that unit productions. So in this grammar we are saying that yes, not yes, this is unit production, and again yes is producing this capital S. This is also one of the unit production. A is producing capital S, small capital B. This is also we have to remove 4 unit productions. Okay, so let's see that. So basically we have to remove these 4 unit productions. Yes produces yes, yes is producing yes, A is producing yes, capital B. So what we will do? For yes we have this production, we will write here. Okay, and for similarly yes is having this production, we will write A produces yes is there, so instead of yes this production without this yes. Okay, and A is producing capital B, so instead of this B we will write this B producing small b by using this production. So after third step, the production looks like S naught is producing capital S, so instead of capital S I am using ASA, then SA, then AS, AB, okay, and this is small a. Okay, so we got S naught producing these many productions. Next, S is producing ASA, SA, AS, AB, and A. So if instead of yes I will write same thing, then again it will come same. So that's why I am not repeating this. These are the productions. Replacing or replacing this yes. Okay. Then next A is producing capital S is there. So again I will repeat these productions ASA, SA, AS, AB, this A. A is producing capital B is there. So instead of that B, I will use this production. So B. Okay. And finally, B is producing small b. Okay. So we got these many productions after the removal of unit productions. Now step 4 and step 5 says that first of all we will see about the step 4, that is if the productions contain more than 2 non-terminals, then we will replace that non-terminal with new symbols. Okay, so like suppose if I will rewrite this production, then I will get instead of SA I will replace that is A dash. Okay, so A dash, SA is okay, AS is B, is A. Next, S is producing. Similarly for this also I will write AA dash, SA, AS, AB, and A. Okay. Again, A is producing ASA, so I will write AA dash, SA, AS, AB, small a, small b. And finally B is producing B. So in this step, what happened? We have removed production like S not producing ASA. So we have replaced SA as dash. So finally I will write A dash is SA. So this is also in the CNF form. Okay, but some productions are not in CNF form. That is, A is producing, S naught is producing small a b, S is producing small a b, A is producing small a b. These three productions are not in CNF. So in fifth step, we will replace that with new variable. Okay. So final step will become, so S naught is producing, just a second, S naught is producing A dash, then SA, yes. And instead of this small a, we have to use another variable, that is non-terminal. So here, suppose I am using capital U instead of that. So UB and small a. It will look like this. S is producing A dash, SA, AS. Instead of A, we have used capital U. This is B and this is small a. Similarly, A is producing A, SA, AS. Instead of small a, we have used capital U, B, A, or small b. B is producing small b, and we know that A dash is used for SA. So A dash is producing SA. This is also okay in CNF. And finally, U is producing small a. Okay, so this is also okay in CNF. Okay, so finally we will check whether all productions are in CNF form. Okay, so CNF form production will look like this. Either A is producing C, or B is producing like A or B. You can say that is one terminal or two non-terminals. So S naught is producing, this is contain two non-terminal, one terminal. Okay, two non-terminals, and finally one terminal. Okay, one terminal. Okay, one terminal. Two non-terminal, two non-terminal, two non-terminal. Okay, so this is also one non-terminal. Sorry, this is one terminal. Okay, this production contain two non-terminals. That is okay, and finally U is producing one terminal. That is also okay. Okay, so this is the example. We have seen that how we can convert the given CFG into a CNF. Okay, so similarly, I will give one question as an assignment to you. You do that, or you try to do that, and once the lecture is over, go through it, and if not getting the solution, then ask me in the comment. I will post question solution in the Telegram. Okay, so let's see that question. Take it as an assignment. So question है, I will write here example 02. Convert the given CFG into CN. So the productions are like this. S is producing capital ASB. Capital A is producing small a, capital A, capital S, small a, epsilon. Similarly, B is producing capital S, B, capital S, capital A, and BB. Okay, so I will explain it in short. So according to that, you try to solve this. So first step says that actually जो algorithm हमने देखा था उसमें first step क्या कहती है कि if start symbol is present in the right hand side, then we have to create new start symbol. तो यहाँ पे S is producing ASB, so क्या start symbol is occurring at right hand side, so we have to create new start symbol. Similarly, this is regarding first step, so we have created suppose S naught as a start symbol. Then step second says that we have to remove the epsilon productions. If the grammar contains epsilon production, then we have to remove that. So A is producing epsilon is there, so we have to remove this epsilon production. Okay, so the steps needed for that, we know that how to eliminate the epsilon. We have to write the productions with or without that nullable variable. Okay, similarly next step says that whether check whether the grammar is having unit productions, and if the grammar is having unit production, then we have to remove that. So here B is producing capital A, so it contains unit productions, so we have to remove this unit production. So follow the steps which we have followed while eliminating the unit productions. And similarly, step 5 says that, step 4 says that if there is a more than two non-terminals, then we have to replace n minus 1 non-terminals with some other symbols till the what step, till n is equal to 2. Okay, and similarly fifth step says that if there is terminal, terminal is present, and after that non-terminals are there, then we have to what replace that terminal by some other non-terminal. Okay, so follow the steps which we have discussed in the algorithm. Go through the algorithm and try to solve this. Okay, so the solution of this I will post in the Telegram group. Okay, I hope you are enjoying these videos, and keep supporting us. Try to share these videos with your friends so that they will get the benefit. Okay, thank you so much. We'll see in the next lecture. Thank you so much.